In this lecture, we're going to do our first network algorithm. This network algorithm is all about finding if two people are connected quickly. Hence, it's called quick find or union find. So networks, let's think of them generally. How do we know if two people are connected? So that's very important in social media. And more recently, it's very important for COVID that two people have interacted. How to define a connection? What do you want? Do you want to show that someone's connected, or do you want to find out who was the first person? Yeah, which is better? So in Facebook, if you friend someone, you're friends. While in Twitter and TikTok, you follow someone. Yeah, they don't have to follow you back. So there's different ways of doing these algorithms. The first mathematical thinking you have to do is reflexive. I am connected to myself. So P is connected to P. So let's have this little grid. 0, 1, 2, 3. Think of them as little computer nodes or individuals in a network. Yeah. And what I'm saying is my computer is connected to itself. That's fair enough. It's a very reasonable thing to assume, but sometimes you don't want that. Yeah. Now, symmetric. This is Facebook. If P is connected to Q, then Q is connected to P. So if 0 is connected to 2, 2 is connected to 0. There's no arrow. In other network models, you can include an arrow saying 0 is connected to 1, 2, but 2 isn't connected to 0. Yeah. But in the examples and the algorithms we're going to do is as soon as you make a connection, you're connected both ways. Now, transitive. If 0 is connected to 1 and 0 is connected to 2, then 1 is connected to 2. If P and Q is connected and Q is connected to OR, then P and OR is connected. Yeah. So that means you don't have to connect. If 0 is connected to 1, connected to 3, you don't have to connect 0 and 3. So think about this in terms of families. And this will become more apparent in the next algorithm is, if I'm related to my sister is related to me. Yeah. If my sister is related to her sister, but then I'm related to that sister as well. That's what we mean by these connections. And if I'm related to this person, and then this person is related there, and this person related here, I don't have to connect myself with that person because that's just a waste of my time. I know I'm connected. Yeah. So you try to make sure it's redundant. So we have reflexive, P is connected to P. Symmetric, P is connected to Q, then it's connected back. My friend is my friend. P is connected to Q and Q is connected to OR, then P is connected to OR. So transitive. And there are 3 properties we're going to keep. So here we start with an example, simple 10 nodes, and that's the examples and the work we'll go through. So with 10 nodes, be they people in a network, be they computers. What operations do we need to combine them? First, we have to make a connection. So make a connection between 2 and 3. How would we do that? What's the best way of representing that? Make another connection. What's the best way of representing that? So the first thing we need to do is ask ourselves, how do we make a group? How do we make a connection? As soon as 2 nodes are together, they're a group. What about a bigger connection? What happens here? Who becomes the dominant in that group? What is that group called? And even bigger groups. So now, are the nodes connected? If 2 nodes are connected, then we don't have to connect them again. If 3 nodes are connected, we don't have to connect them again. If 4 nodes are connected, we don't have to connect them again. So are these connected? Can you see it? Maybe you can't, maybe you can. This is a small representation, but think of these as every single mobile phone device is somewhere in the world and they're always moving. And the question is, are they connected to other mobile phone devices? Who are they connected to? How are they connected? Here they are connected. But let's say, for example, if I said that one, is this one connected to this one over here? Of course not. They're isolated groups. So we know what group are you in? Who are you connected to? And lastly, how many different groups are there? So To do this, we actually have to set it up, and it's nice to set it up in this tabular form. So we have our graph here, which tells us we have 10 nodes, our 10 objects. Yeah. And then we give them all an ID. And because none of them are connected, we may as well give them all a unique ID, and may as well just give them the ID that's associated with the object. So the ID of 0 is 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5. Object tells you which one it is. ID tells you its relationship. So let's make a connection. I want to connect ID2 and ID3. So that means I want to connect these two. Yeah, I want to connect those nodes. So how do I do it? Well, I just let the IDs be the same. So here, I've connected them. And now I've changed my ID. I've connected 3 and 2. And I've changed the ID of 3. Now, the computer is going to forget the original one. And now this is all it knows. And it still knows the top. But now it only has this, which it tells you the ID, the new ID. Yeah. And so if I said, are 2 and 3 connected? Do they have the same ID? Oh yeah, they are. Does 4 and 5 have the same ID? No, not connected. We can see that in the group. So now let's make another connection. 0 to 1. So we're connecting 1 to 0. And so always the second one is the dominant one. That's the one you're connecting to. Yeah, you're asking for that connection, and it's going to. So now the ID of 1 becomes 0. Very straightforward. So if we did in a different order, if we connect 0 to 1, the IDs are different. But they're the same ID. It's just in case of 0, 0, it's 1, 1. Are the nodes connected? As I said, this is the beginning of our pseudocode. If you have 2 IDs, so we're asking is object P and Q connected? We find out what their ID is, and we check if they're connected by saying if PID is equal to QID, they are connected. And if it's not, they're not connected. That's straightforward. So make another connection. We're going to connect 3 to 8. Now, what happens here? If we go back, we had 2 and 3 connected. So they became 2 and 2. But when we're connecting 3 to 8, anything that was connected to 3, which was 2 in this case, gets connected with 8, and they all take 8 as the name because I connect 3 to 8. If I connected 8 to 3, then 8 would get the ID of 2 because that was the ID of 3. So what group is a node in? You connect. So how do we connect? We have to check. So connecting 2 nodes is, first, if 2 nodes are already connected, we stop our algorithm. Yeah, we don't have to do anything. If they're not connected, then what we do is we loop our way through each of the nodes and say, what's the ID? Is it the same ID as the group we want to join? That's joining? Yes, change it. Change it, change it, change it. So let's go back to this. You see here, it's 2 and 2. So what the algorithm does was, okay, I'm connecting 3, which is an ID of 2, to 8. Now, if I was just connecting it, normally I change that to 8. But I have to find anyone else who has number 2 and change that to 8 as well. And then how many groups? So what do we have here? How many groups? 1 group, 2 groups, and then all the individuals, 3, 4, 5, 6, 7. There are 7 groups. Yeah. But we've done 4 connections. Why is the last connection not part? Because 2 is already connected to 8. So we don't have to do that one. So how do we connect groups? Every time we make a connection, we subtract a count. So what we have to pass in, if we want to connect two nodes, we pass in P, which is the node object, Q, which is the other object, ID, which is the ID for everything, count, which is a number of groups. So these are the four things you need to figure out, are they connected? And what I normally do is I create an extra column that's called groups. We start with 10 groups, yeah? Then we make one connection, so there's 9 groups. Why is it 9? Because as soon as you make a connection, two nodes become one group, and that's one less group. Then we make another connection, we go to 8, another connection to 7. And 7 again here is because 2 is already part of 8, 2 and 8 are already connected, so we don't make a new group. So this is our pseudocode. The first part gets the IDs. The second part checks if it's connected. If they're connected, it ends. Here, if they're not connected, it goes through and finds, if you're part of the group that's being connected to, change your ID to the new group. And then give the new ID and new count, and that's the end of it. So, make a connection. Are they connected? How many groups? Are they in the same group? How many groups? There are 4 steps. Make a connection. Are the nodes connected? What group is a node in, and how many groups? So in the flowchart form, what we have here is we pass in P, Q, ID, and count. We check, we get the IDs, and we start our loop. If P, ID, and QID are the same, we jump to the end. If they're not, so if they're the same, you just exit out. If they're different, you have to loop. So you go and say, okay, is there anything the same as PID there? Yeah. If there is, change to QID and go round and round and check every single node, in this case, 10 nodes. And when you're finished connecting, reduce the count. But see here, note, if they're connected, I don't go to count because I don't decrease the number of groups. I just exit immediately. So, is it any good? How fast is it at connecting? Union takes time. It takes n operation as it has a connecting loop. So that means that if you have a million people and 2 people connect, it has to do a million operations. But if I ask are 2 people connected, it just has to check one operation. So it's very fast to find if they're connected, but it's not very fast to see they're connected. So the next algorithm we're going to look at is the opposite. It combines things very quickly, but it's hard to find if they're connected. And there's reasons for that. So here we have our pseudocode and our flowchart. In class, I'm going to do a couple of written examples of this, and you'll also work your way through. In the next lecture, I'm going to do the quick union, which is, as I say, the extension of this, where it's able to combine things quickly, but it's hard to find if things are connected.